Hi everyone, welcome to our physics class. In our daily life, we see lots of things moving around. For example, car passing through from one place to other, person riding on a bicycle, and many more like this. In scientific terms, an object is said to be in motion if it changes its position with respect to its surroundings. Today, I'm going to discuss about motion along a straight line. The total duration of this chapter is 8 hours and it is possible to ask 7 marks. Okay, let's start today's class. So first here, let us discuss about some very important basic terms. The first one is mechanics. So what is the meaning of mechanics? Mechanics is the study of motion. Mechanics is the study of motion or states of material particles under the action of forces. So what is the meaning of mechanics? Mechanics means the study of motion or the states of material particles. Study of motion or states of material particles under the action under the action of forces. Look at this animation. So this one shows the mechanics. Mechanics means what? The study of the motion or the states of material particles. Study of motion or states of material particles under the action of force. What is the meaning of force? Force means something which changes the state of rest, something which changes the state of rest or of uniform motion in a straight line. That is the meaning of force. So mechanics means the study of motion or the states of the material particles, material bodies under the action of forces. So it is mainly divided into two branches. One is statics and another one is dynamics. So statics means study of objects at rest. It is very simple. The study of objects at rest is statics. So when the object is said to be at rest, if the object does not change its position, object does not change its position with respect to its surroundings. Okay, so that is the meaning of statics. And another branch, that is dynamics. Dynamics means the motion, study of motion of the objects, study of objects which are in motion. That is the meaning of dynamics. Statics deals with the study of objects at rest. Dynamics deals with the study of objects and motion. When the object is said to be at rest, if the object does not change its position with respect to its surroundings. So when the object is said to be in motion, the object changes its position with respect to its surroundings. Then the object is said to be in motion. For example, a driver in a moving bus is in motion with respect to a person outside the bus. But with respect to person sitting inside the bus, is at rest? Is it not? A driver in a moving bus is in motion with respect to a person outside the bus. But with respect to person sitting inside the bus is at rest. So that is an example for rest and motion. So when the object is said to be at rest, if The object does not change its position with respect to its surroundings. Okay, so when the object is said to be in motion, the object changes its position with respect to its surroundings, then the object is said to be in motion. So statics deals with the study of objects at rest. Dynamics deals with the study of objects in motion. So look at this animation. So this is dynamics. That means the study of motion of the objects. So with respect to its surrounding, that is actually called dynamics. So dynamics is further divided into two types. One is kinematics and another one is dynamics. So one is kinematics and another one is dynamics itself. So kinematics means the study of motion of objects, but without considering the causes of the motion. Without considering the causes of motion, that is kinematics. So this is actually here kinematics, study of motion, motion of objects, but without considering any causes. That means time, velocity, speed, acceleration. So it does not consider those things. Okay, the study of motion of objects, the study of motion of objects without considering the causes, without considering the causes of motion. So that is called the kinematics. So dynamics means the study of motion of objects taking into consideration the causes of motion. The study of motion of the object taking into consideration the causes. That means the speed and the distance traveled by the object. So that is considered in this case. But here we won't consider the speed, velocity, acceleration of the object. Okay, the study of motion of object without considering the causes of motion, that is kinematics, taking into consideration the causes of motion, that is dynamics. What is the meaning of mechanics? Mechanics is the study of motion. Mechanics means the study of motion or the states of material particles under the action of force. So mechanics is mainly divided into two branches, statics and dynamics. Statics, that deals with the study of objects at rest. When the object is said to be at rest, if the object does not change its position with respect to its surroundings. When the object is said to be in motion, if the object changes its position with respect to its surroundings, so then the object is said to be in motion. What is the meaning of dynamics? So this deals with the study of objects in motion. So dynamics is further divided into two types. One is kinematics and another one is dynamics. Kinematics means the study of motion of objects without considering the causes of motion. So dynamics means the study of motion of objects but taking into consideration the causes of motion. So that is dynamics. Okay. The next topic, that is motion in one dimension. Actually, depending on the number of Cartesian coordinates and the number of directions needed to specify the position of a particle, the motion is divided into three types. Number one, the motion in one dimension. So motion in one dimension means if a particle just moving along a straight line. If a particle moving along a straight line, particle or an object, anything, it is moving along a straight line. That is motion in one dimension. For example, a car that is moving along a straight road, or a train moving along a straight track, that is motion in one dimension, or a freely falling body. So this is actually a freely falling body. What is the meaning of a freely falling body? When an object falls under the action of Earth's gravitational force of attraction, that is actually called the freely falling body. When an object falls under the action of Earth's gravitational force of attraction, that is called a freely falling body. Actually, this is moving along a straight line. This is motion in one dimension. So this is also motion in one dimension. Okay. So what is the meaning of motion in one dimension? A particle moving along a straight line, a particle or an object moving along a straight line, that is motion in one dimension. Okay, so in motion in one dimension, the change in position of a particle, so change in position of a particle, so that can be determined by using only the one Cartesian coordinate. So first here, let us consider the three axes. X, Y, and Z. Okay, this is x-axis. This one is x-axis. This is y-axis. This one is z-axis. Suppose if a particle is moving from P to Q, a particle that is moving from P to Q. This is the point P. This one is the point Q. So here, the particle moving only along the positive x-axis. So the initial position of the particle is x1, and the final position of the particle is x2. So what is the change in position of the particle? The change in position of the particle is x2 minus x1. So here, the change in position of the particle that can be determined by using only one Cartesian coordinate, that is x. Suppose if a particle moving along y direction, the change in position of a particle that can be determined by using y coordinate. If a particle moving along z axis, the change in position of a particle that can be determined by using only one Cartesian coordinate, that is z. Okay. So if a particle moving along x direction, that is motion in one dimension. If a particle moving only along y direction, that is also motion in one dimension. If a particle moving along only z direction, that is also motion in one dimension. So in one dimensional motion, particle moving along a straight line. Particle moves only one direction. So only one coordinate is needed to specify the change of position of the particle. Only one coordinate is needed to specify the change of position of the particle. So when a particle is said to be in one dimension, a particle moving along a straight line, either x-axis or y-axis or z-axis. Okay, in one dimensional motion, only one coordinate is needed to specify the change of position of the particle. So the particle moves only along its straight line. One dimensional motion, The particle moves along a straight line. Okay, the particle moves only in one direction, moving along a straight line. For example, motion of car along a straight road, motion of a train along a straight track, motion of a freely falling body. So those are the examples of motion in one dimension. Okay. So the next type, that is motion in two dimensions. Motion in two dimensions. If a particle moves along a plane, then its motion is said to be two-dimensional motion. Okay. So first here, look at this animation. If a car moving along a straight road, that is motion in one dimension. If a car moving along a curved road, so this is motion in two dimensions. So another example, motion of planets around the sun. Okay, each and every planet revolving around the sun in an elliptical orbit. Is it not? All the planets are moving around the sun in an elliptical orbit. So the motion of planets around the sun, actually this is an example for motion in two dimension. Okay, motion of car along a curved road, motion of planets around the sun. So this is the example for motion in two dimension. So when a particle is said to be moving in two-dimensional motion, the particle moving along a plane. Okay, the particle moving along a plane, then its motion is said to be a motion in two dimension. So in two-dimensional motion, the particle moving in two different directions at the same time. So just consider again here three axes. X axis, one is the y axis, this is the z axis. Okay. Now a particle is moving like that. It is along a plane. Okay. So here this is the initial position and this is the final position of the particle. So P is the initial position of the particle, Q is the final position of the particle. Here the initial position, that is initial position of the particle, let us consider that is x1 comma y1. So this is the initial position of the particle. Along x-axis, the position of the particle is x1, and along y-axis, the position of the particle is y1. Okay, and the final position of the particle along x-axis, let us consider that is x2, and the final position of the particle along y-axis is y2. So here the final position is x2, y2. So here the change in position of a particle that can be determined by using two Cartesian coordinates, that is x and y axis. So here particle moving in two different directions at the same time. Is it not? The particle moving from P to Q. So here particle is moving in two different directions, it means x and y direction at the same time. Okay. So the change in position of a particle that can be determined by using two Cartesian coordinates. So here particle is moving along a plane. So for example, a car moving along a curved road, motion of planets around the sun. So those are the examples. And the next type of motion, that is motion in three dimension. Motion in three dimension. So if a particle moving in space, if a particle moving in space, that is called actually motion in three dimension. Look at this animation. If a particle moving, actually here particle is moving in space. Particle is moving in three different directions at the same time. If a particle moving in space, then the particle is moving in three different directions at the same time. Particle is moving in three different directions at the same time. So the change in position of a particle that can be determined by using three Cartesian coordinates, that is x, y, z. Okay. So here again, let us consider three axes: x-axis, the y-axis, the z-axis. The particle actually moving from like this. So the particle is moving in space. Okay, particle is moving in space. So here the position of the particle. Particle is moving like this. Here the position is x1, y1, z1. Here the position of the particle is x2, y2, z2. So the change in position of particle, so that can be determined by using three Cartesian coordinates: x, y, z. So motion of butterfly in search of honey, that is an example for motion in three dimension. Okay, thank you.